Okay, hello everybody. I'd like to present a short example of using SuperSlicer to reconstruct some bone and then briefly visualize it. And so let's get going. The first things first is that I've already unzipped the files into a particular directory on my computer. This is my working directory. And I've unzipped the SS release files, which contains all the code. And here's the images, which contains all the MRI images in the sequence. Now, the first thing you have to do is you have to add the SS release code to your path. So I've already done that, but we'll just examine that, set the path. Here it is. Here's the path, no spaces. I prefer not to have spaces in my paths. And for now, I'll just close this because I've already done it, but you can do that. Okay, now we're ready to run SuperSlicer. So just get that started. Oh, before we run it, make sure you're in the directory where your images are located. Okay? And we'll run SuperSlicer. I just want to note that sometimes SuperSlicer has trouble opening the first image. I'm not sure what this is. This is some bug with R210B MATLAB. But you get this subscripted assignment dimension mismatch. You just close SuperSlicer and redo it. It fixes itself. Okay, so here we go, SuperSlicer. Okay, here's the main GUI window. All right. You can see where the window where the images will be displayed, all the buttons, etc. So I'm going to open the sequence of images, load images. I'll start with this Achilles 4 image because that's where I can see the tibia clearly. And then I'll end with, let's say, this Achilles 28 image where the tibia is at the end. Oops, I made a mistake. Do it again. Load images. First image, last image. Okay, now we can see the images are loading in green in the bottom there. And there we go, our initial SuperSlicer window. You can see the contours are by default automatically selected. Okay, let's just walk through the images a little bit just to see what this looks like. And it appears that the area that I want to segment, this tibia, is localized in this region. So the first thing I'm going to do is I'm going to crop the images. Okay, so let's go back to the first one. I'm going to go Edit, Crop Images, select this region, probably that's fine, and then double click in the crop region, and there we go. So now everything goes much faster. Okay, so the first thing we can see is this is very jagged, and so we don't really necessarily want our to capture every little detail here. So I'm going to just initially, the first thing I'm going to do is just add a number 3 median filter. That just smooths it just a little bit. Okay, let's raise the contour threshold up a bit. Okay, now it looks like we're capturing the cortical bone. So this is our contour filter. Let's go back to the first image. This is our contour threshold set at 29. I'm going to, just because I'm starting out this way, I'm going to add a keyframe. Alright, now I'm going to start walking through the images. It looks good, this looks good, this looks good, this looks good, looks good, 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 good. Okay, so it looks like I'm capturing the the cortical bone of the tibia pretty well. Now I'm starting to miss it here, but you can try and improve on that by adding keyframes. For instance, I'll add a keyframe here, and then maybe I'll progress a little further, and I want to capture this, so I will increase the contour threshold a little bit so that it meets again, and I'll add another keyframe. And you can keep on trying to do that just to see how good you can get. Okay, how far along the tibia you can capture. Okay, so we want to capture the cortical bone, which means that we don't want to capture this inner region. We consider this a hole, so we want to say include holes. All right, and as far as that goes, we're ready to go. And we're going to hit Super Slice. Oh, there is one thing. We can only slice up to a certain point. Obviously, I'm not capturing the bone at this point. So up to the point where you're satisfied you've captured the bone, you want to look and see what frame that is, or what slice. This is slice 17. So we want this super slicing to stop at slice 17. All right? So let's go, once again, go back and super slice. Here we go. Aha. Well, it looked good, but what happened? I'll explain this in a second. So this looks good so far, but on this frame, we've accidentally captured a piece that we don't want. Okay, the only thing we can do it from that point on is we just want to remove these contours that we've captured. The reason is because it was too close to the cortical bone. So we'll just have to go through and manually delete these contours. It's a little bit painful, but we'll do it one by one. Delete. There's faster ways to do this, but it's too complicated to explain in the short video. So I'm just going to do it this way. Okay. Okay. Almost there. Painful. I'm double clicking inside each of these contours in order to deselect. Okay, now it's deselected. Okay, so now let's go back to the beginning again, and just to see how it looks, just get a basic idea. We can see the three-dimensional view here of the contours, and this looks pretty good. All right. Okay. So now we're ready to go ahead and generate our object. But before we do that, we've got to set our scale factors. How are we going to do that? We need to know something about the image. So let's look at one of these images. I'll just pick number 11. I'm going to cheat a little. I can easily just double click on one of these images, and it will appear in the workspace. And then I can type figure. You have to type figure here, otherwise it'll go into the super slicer window. Figure IM show Achilles 17. All right. Aha, so now we can see the figure. We can see this actual image. And we can see that there's a scale bar, and we know the image is 512 by 512. So this is easy. All we have to do is use IM pixel view, or IM pixel info, that is. Go back to the image, and as you can see, we get the info of where the pixels are. So let's see, this pixel is the end of the scale is located about 311 or 310, and the beginning of the scale is located about 200 or so. So 310 minus 200 is 110. 110 pixels, 3 centimeters. So that's 30 millimeters divided by 110. That's 0.2727. Now, looking carefully again at this window, we also see that the thickness is 4. So that probably means 4 millimeters per section. Okay, so we can close this now. Go back to the super slicer window. And what was that number again? 0.2727. Whoa. There we go. 0.2727. Tab 0.2727. And then it's 4 millimeters per slice. Okay, so now we're ready. We're ready to go surface generator, and we're going to generate the surface using all the default values just for now. Okay, let's hit go. And it says busy, please wait. Oh, great. So what pops up? But the it pops up a window where you can save your file. Give it a name. I'm going to call it tibtest2. I already did this once. And hit save, and it's saved. Okay, and it should say file saved to some images. Now, just for the heck of it, I'm going to try removing the virtual smoothing slices, just so that we can take a look at that. So I'm going to hit surface generator again, and it'll say busy, and this time I'm going to say tibtest2, let's say tibtest3. Okay, files are saved. So now we're done. We're done with SuperSlicer. We've contoured out this cortical bone of the tibia. Now, just so that I can go back someday later, I might as well save the project. Save project, and I'll save it as tibtest2.trc. All right, saved. Now I can close SuperSlicer. All right. Now what do we do? Well, if we look in the directory, we'll see that there are some mat files and there are some object files. Well, all we want to do for this little example is take a look at this object file. So in order to do that, you're going to use a different program. The program is called GLC Player, and I'll send you the link to download the program. So if I go to the Achilles images directory, I see that the objects are here, all right, and we're going to look at tibtest2 object, and by default it should open in the GLC player. Okay, GLC player. This is a very nice free player you can download and install on your computer in order to visualize objects in 3D. And so there we have it. This is our sectioned tibia bone, and we can just view it. You can apply some surface viewing type things to it as well. But this at least gives you an idea of what you've reconstructed. All right, and for the heck of it, let's go ahead and open. Let's go ahead and open the other tibtest3 and see what it looks like. Okay, tibtest3 looks a little different. I thought they would open on the same screen, but they don't. tibtest3 doesn't have the virtual slices. It looks almost the same. So having virtual slices for this reconstruction probably doesn't really help much. All right. One thing you can clearly see though is how jagged it is. The next term, when we really start working on these reconstructions, we're going to see how to remove all of these artifacts. Okay, that's about it for this tutorial. So you should be able to do your reconstructions from here on. Bye-bye.